Okay, for those of you watching, we're referencing question number 7 on the test. And what problem number, page is it?
137, number 19.
137, number 1. Okay, this is classic, this is asked a lot. And by the way, the one on the test does not have a part F. Just goes A through E. It's the same A through E, but pertaining to a different question, or different function. Okay, so on number 19 it says, a particle moves along a line so that its position at any time t greater than 0 is given by this function. That's position function. And the one on here, on number 7 on the test, is also a position function. And just so you know, it's also a polynomial, just like this one. Not exactly like this one, it's a polynomial, that's all I'm going to say. That's the type of function it is. S is measured in meters and T is measured in seconds. And you need to pay attention to that because, having been warned right now, if you fail to put units on your answers, I will mark some, you will lose some points. So put units, when they tell you what things are measured in, they are trying to tell you in an obscure way, put units on your answers, please. Okay? All right, so our position function is t squared minus 3t plus 2. Pretty simple parabola. Quadratic. A says find the displacement during the first 5 seconds. I'll put A over here. We may need to do something with that thing. Displacement? 4 or 5 seconds. First 5. Okay. How are you going to do that?
Let's plug in 0 and then plug in 5 for t.
And?
Subtract them. Add them.
Yep, subtract them.
I've got a question. Displacement is just it's not like the entire distance that you move. So like if you went back like -3 and then 5, that'd be 8.
That's the distance of 8. Displacement is just how far are you now from where you started.
Okay.
That's it. And to do that, you would find, as was mentioned, S of 5 minus S of 0. And you guys, I hope I've beat it into you well enough. Do you know the biggest mistake people make? They forget the 0. They think it's 0. They think all particles start at 0, and they don't. These are time elements. This is 5 seconds. This is 0 seconds. How far do we go from 0 to 5 seconds? That's what we're doing. Is where are we now minus where do we start? That's how far we've gone. I'm sorry. That's how far we are from the beginning point. Right? All right. So S of 5 is what? Let's see. It'd be 25 minus 15 is 10 plus 2 is 12.
Yep.
S of 0 is not 0. S of 0 is 2. So the answer is 10. 10 what?
10 meters.
Meters. And does that mean that you are, it doesn't ask this question, but I just want to know if you got a feel for it. Does that mean that you are to the right or to the left of the start point?
Right.
Why? Because it's positive. Good job. Okay. So we're okay on that part? You asked it. I want to make sure we're cool with everything we're doing with you. Okay.
I just forgot that you had to subtract this from 0.
Uh-huh. That's a big mistake. Sorry. Not a big mistake. It's a mistake. Very common. Still a mistake. B part, find the average velocity during the first 5 seconds. Operative word here is?
Velocity.
Average.
I said that.
Average velocity. How do we find average velocity? No, you don't. Take the derivative. You don't need it yet. Derivatives are for instantaneous things. That's why they were invented. That's why people thought about it for hundreds of years. Figure out how fast something's going right now. Average velocity has been known since men and women could figure. What's the definition of average velocity?
How long it takes to go from one point to the next.
No, that's a time thing. What's average velocity? Total distance. Yeah. Actually, sorry. Average velocity is not distance over time. It's displacement over time. It's displacement.
So you would
It
take,
takes into account all the moving forward, moving backward, moving forward. It averages all that stuff together if you do displacement over time. And this says, what's the average velocity for the first 5 seconds? Well, since they're asking it about 5 seconds, if they're asking about something else, you'd have some more figuring to do. But since they're asking about the first 5 seconds, the average velocity is going to be displacement, which we already figured, over time.
it's 5 seconds.
So it is 2, what?
Meters a second.
Meters per second. Now, had they said, what's average velocity for over the first 7 seconds, then you would have had to refigure this. You had to go S of 7 minus S of 0. But since they asked for 5, we were able to just take that answer and put it here. I'm not going to tell you which way it is on the test. You figure it out. You think about it. You think about it. Okay. You okay with that? Yeah? Okay. Was number 1 the only problem? I mean,
I
A?
think so. I think I can figure the rest of this out.
You want me to go through the rest of it, everybody? or
Yeah,
not?
sure.
Yes.
Sure.
Okay. C, find the instantaneous velocity when t is 4. Oh, we've gotten off the 5, now we're at 4, and we're talking instantaneous. So what do we need?
Derivative.
Now we need a derivative. We need a v, which is,
2t minus 3.
and what do we need here? How could we write it?
Little tick mark.
V of 4.
Yeah.
We have v of t. V of 4 is going to be 8 minus 3. 5 what?
Meters per second squared.
Meters per second. These are both velocities. They're both meters per second.
That's on me.
Okay. Everybody okay with that one? See what's going on? D, find the acceleration of the particle when t is 4.
Yeah, there we go.
So now we need
Acceleration.
acceleration, which is
Derivative of the derivative.
2.
2. So what's the velocity when t equals 4? The same as it is at any other time, right?
Yep.
So I would say a of 4 here, and it's 2. 2 what?
Kyle.
Kyle?
Second squared.
Yeah. Meters per second is what's going on. I will tell you this, folks. The polynomial you'll be dealing with for position on the test is not a quadratic, which means your acceleration will have something to plug in. It's higher than quadratic.
That's good.
Anyway, all right. Okay, E part. At what values of t does the particle change direction?
You just solve as the velocity equals 0, right?
Yes, and then verify that velocity actually changes in sign at that point.
Okay.
It will, it's linear. It has to. It's linear. So you can count on whatever zeros you get out of velocity, because it's linear, it's going up like this. It'll tell you the one place it crosses the x-axis. So to do the E part, we say 0 is equal to 2t minus 3, and we get that t is 3 halves. Do you agree? 3 halves what?
Seconds.
Seconds. You may write it 3 halves, you may write it 1.5. Please don't write it 1.5. Okay, so make sure you got units on all of those things. There will be no part F. Do you have any questions about this one, or do you want to move on? Okay. This, what I've shown you on the board, would be a really, really excellent way of showing you your work. I know there's not much work over here, but these kinds of notations here in the front, and these notations here, and these kinds of things coming down, even if you show me your work over here, or if you want on this one, you can show your work here as well, kind of like that, would just be 0 equals 2t minus 3, t equals 3 half seconds. When you're showing me your work, you don't put this in the answer blank. You only put this in the answer blank. And you only put this in the answers, just these. But to show me your work, it might be really nice if you would organize it something like that so that I can see what you're using and what you're plugging in. Stuff. Okay? So that's number 7. Other questions?
Can we do number 10, which is
Okay.
number 30 on page 146?
Hang on to that reference for just a second. Let me get rid of this stuff.
Do we have to use that, F of A equals H minus F of A over H? Do we have to use
I
that?
haven't looked at it yet. Number 10?
Not on number 10, just in general on this test. Or could we just use the special derivative thing?
I don't know what you're talking about.
Do we have to plug it into the main equation that it gave us for derivatives at the beginning of the chapter, or can we just do the?
Oh, no, you only do that once on the first one.
We do have to use it on the first one then?
Yeah, we're, those of you watching, we're skipping just a little bit here. The only time you have to use the definition, the only time you have to use the definition for a derivative is on number one. And you had better be able to show all of it, because the points on this are not for getting the derivative. That would be easy. The points are for using the definition to get the derivative. Okay? So, and there's only a blank. See, look, this is what it looks like. There's only a small blank right there, which means you're gonna say, see work or see back in test or reference me somewhere else, probably, because you can't put all that right there. The answer is the process, okay, for number one. After that, you can use any trick that I taught you. That's what this whole thing's about, okay?
Good.
All right, number 10. Where's the reference on that?
Number 30, page 146.
Page 146, number 30. All right, number 30 says, find the points on the curve y equals tangent x between negative pi halves and pi halves. That means first branch of it that goes through the origin. Where the tangent is parallel to the line y equals 2x. What's the slope of the line they gave us? 2. Then we want to find points on the curve, the tangent curve, the first branch of the tangent curve that goes through the origin and has asymptotes at negative pi halves and pi halves. That's what they're telling you. We're going to find the places or places on that curve that have a slope of 2. Okay. And of course, in calculus, we find slopes of things with derivatives. Okay, and what I want to know is, when is secant squared x equal to 2? Restricting the places I can look to negative pi halves to pi halves. You know what I'm saying?
Yeah.
Okay. All right, so I need to set this thing equal to 2. That means, and if you've forgotten your trig, that means that 1 over the cosine squared of x equals 2, because this is just a rewriting of secant. It's still equal to 2. Now, you can either think of cross multiplying, you can think of reciprocating. There's a couple ways you can do this. But what it comes down to is, when is the cosine squared of x equal to 1/2? Because that would be 1 equals 2 cosine squared, and then you would divide by 2 and get cosine squared equals 1/2. Or you could turn that over so you get cosine squared. You have to turn them both over, you get 1/2. Either way you think about it, that's what we're asking, right? Which means what we're really asking is, when is the cosine of x equal to plus or minus the square root of 2 over 2? Do you all see that or not? Okay. The square root of 1/2 is the square root of 1 over the square root of 2. When rationalized is root 2 over 2. And since we are square rooting in the process of solving, you need a plus or minus. Okay? And we are only allowed to look between negative pi halves and pi halves. Now, on a graph for the original function tangent, that would be between here and here. But for this part of it right here, it's easier for me anyway, personally, to think of it as I'm only allowed to look from here to there for answers. Because this is negative pi halves, and this is pi halves on the inner circle. I just tend to think that way better. Okay? So where does the cosine have root 2 over 2 or negative root 2 over 2 in those two quadrants for its cosine? Pi fourths in both places. It's root 2 over 2 for pi fourths. It's negative root, oh no. Cosine in the fourth quadrant is also positive. X 2 over 2. I'm only getting root 2 over 2. I'm only getting the positive aspect of that, where in the places I'm allowed to look.
Still be negative though?
What's that?
Wouldn't the reference angle still be negative pi fourths? Like you.
Oh yeah.
The cosine is negative, but all right. I mean, it would be.
Oh yeah. You're right. The cosine. So this value right here would either be pi fourths going up for a positive root 2 over 2, or negative pi fourths in that region we're looking for, and it's still positive root 2 over 2. So there's no negative to look at. But you're right. There's two values that we get. Thank you for that. I was gonna lose my mind there. Okay. So x is either plus or minus 5/4. Good job, Kyle. Well done. Okay, so what we're saying is right here at 5/4, if we come up here to the tangent curve and draw a line, a tangent line, it has a slope of 2. And if we come back here to negative 5/4 and draw that very well, we also have come down here to the curve and draw a tangent line that also has a slope of 2. Other questions or more discussion?
I have a question on the same one. It says find the points on the curve, so do we gotta find the y
Oh,
values
yeah,
that
you
go
do.
with 5/4?
You do. Tangent of 5/4 is 1 or negative 1. So the answer is not this. The answer is 5/4, 5/4 1 and negative 5/4 negative 1. These 2 points right there and right there. Boy, glad I'm taking this test. Good luck, y'all. Great.
So you just plug the 5/4 back into the
Tangent.
tangent, okay?
Yeah, you want to find points on the original curve where it happened. Tangent of 5/4 anywhere is a 1 of some sort. Any more discussion on that one? That was problem number 10 on the test. Let me take a look at it, make sure there's no delineations away from it. Nope, it's good. 10, just so you know, number 10 is worth a lot of points. Other questions, anyone? Come on, this is a recorded test review. We gotta have something.
Let's just go over number 2.
That's a good idea.
Okay. And number 2 references what?
13 through 16, page 105.
Page 105, number 116,
13 through 16.
13 through 16. This is another one that people struggle with. I would suggest that you take these problems and practice them until you can do them without wondering if you're doing them right. What was it was page 105, numbers what?
13 through 16.
Match the graph of the function with the graph of the derivative shown here. Okay, you're not gonna like this at all. I'm gonna make up one of my own and we're gonna do it together and then you can make up one similar to it all day long until you get it straight. But you don't get to match them on the test. There's no matching. What they're gonna do is show you a derivative graph. And you have to draw a possible function for it. So you're gonna get the graph of a derivative. And you have to draw the derivative's original. Okay? Now, as you know, when you take the derivative, if the original function, when you do a derivative of a function, if it had a constant on it, the constant is 0, right?
Yep.
And it is the constant on a function that moves it up and down this way. The shape remains the same, but it moves it up and down on the y-axis. So you will not be graded on where you put it. Just that you make certain turns and certain things happen in certain places on the front with an X reference. So vertically, where you put it will not be graded, or whether you make things really terribly extreme or not too much is not going to be graded either. I do believe on this thing, though, they do tell you one of the points it has to go through, and that will kind of pin it in where it goes. So I like it. It does matter where you put it vertically because they're going to say it has to go through this point, which means you can only do certain things with it vertically. The vertical stretches and stuff like that are not going to be graded because you can't tell, but you will have to make it go through a certain point. And by the way, just so you know, that point is offered to you in function notation like this. It may have to go through f of 2, 3. Sorry, f of 2 equals 3. Kind of combine both ideas together there. That'll tell you that point, so that means you plot the point 2, 3 first. And make sure that the graph that you produce goes through that point. Okay? I'm not going to do that. I'm just saying this is the way it's going to be offered. This is what the graph of the derivative that I'm going to practice with you on looks like, and it's a lot like, it has the same kind of things as your test does. So what it does is it draws a couple axes right smack through the middle, so the origin is right in the middle. Put some tick marks on things. 1, 2, 3, 4. Pretend those are evenly spaced. These are down 3. So, and it tells you at the bottom so that you know the tick marks. It goes from -4 to 4. And I'm even writing this right from the test so that you know how big it is on the test as well. So this is what they're giving you, is a graph like this that's got stuff like this on it. Actually, there's a hole there. That's a derivative graph, and you were to draw the original function. And over in the answer column, it gives you a blank graph like this. And let me see if they put axes in it. I think they do. It has to be the same axes. Yep, -4, 3, that's what you get to draw on. So your answer on the answer page over in the column looks like this, has the same size, everything. It's supposed to be evenly spaced. Okay. And so now we have to produce the original function that has this for its derivative.
The slope is probably pretty steep at first.
Mhm.
Good idea, Kyle.
It's not that steep. It's not that steep. At first, it's -2. The slope is -2. Yeah, don't think backwards. We're not talking about the slope. This is the derivative.
First, half of the graph look kind of like x cubed.
Like a negative x cubed. It kind of like goes negative and then it flattens out.
Mhm. Where does it flatten out?
-1.
-1. And is it,
So that's where it
so is the slope positive or negative? Well, if you're gonna draw it left to right, so are the slopes positive or negative?
is negative.
Negative. Starting where? Oh, I didn't give you a point. I'll say it has to go through, well, this has to be a point. F of -1 equals 1. So you should plot that. Has to go through that point. What's going to happen at that point? Can you tell? It'll be flat for just a second because the slope is 0 at -1 when x is -1. Does this make any sense to any of you?
Yeah.
Some of you are nodding your heads and some of you are going, I don't know what she's talking about. Remember, these things over here are values of slopes. Value of that slope. The value of the slope I'm going to draw when x is -1 is 0. It's got to be flat there. It's also going to be flat here. Or maybe not flat, but at least have a horizontal tangent. Right? Okay, so what's going to happen before we get to -1? What kind of slope will it have? Negative. Negative. Steep. And then flattening. Yeah? What? You see it? So right here, it's going to be flat. But before it, it's going to be decreasing, coming down because the slope is negative. And as we go from -2 to -1, it's going to be flattening. It's pretty steep at first and flattens. After that, it's still going to be, it's going to be flat. I mean, it's going to not have a very steep slope for a minute, but it's still going to be a negative slope and going down until it gets to 0, right? Okay. So where is it going to hit the y-axis? And the answer is, it doesn't matter. I'm going to hit it right there. So now I've got this one drawn. Does that make any sense?
So it doesn't have to hit 0 or nothing?
No. It just has to hit the y-axis. It's the x values that matter. Okay? I did not hit it at the origin. You can if you want, but it's not necessary. I could have hit it down here someplace. It doesn't matter. As long as you've got it flattening here and coming down, we could hit it there if you want. That's okay. That's kind of a crappy looking graph, but it represents the basic ideas here. Then what happens?
It starts to show up.
And it just changes.
So what is the slope? If I were to draw a tangent line right here, what would the slope be for what I've gotten drawn so far? -2. And what will be the slope as we switch from going from here up to here? What will be the slope? -1. And it will be -1. Okay, -1. Okay. And then what will happen when we get to 2?
It'll turn around.
What will turn around? The
slopes are going upward.
The slopes are still negative until we get to 2, right? But not as steep as they are here.
Yep.
So maybe like this. Right? Still negative, still coming down, still decreasing, but the slope right here, as I switch from this piece of it to this piece, the slope is still negative because we're still down below the x-axis, but it's not as bad as it was here, and it's a corner. So it says a slope of -1. And then by the time it gets to x equals 2, what will the slope become? And then what? Positive. Kind of a piece of a parabola.
Okay, so if you did draw like an absolute value function, would that be wrong because the slope would be?
It would be wrong because it's a -2 here and a -1 here. And if you headed up, if you got to here and headed up, that would indicate that you believe the slope is positive there, and it isn't.
Well, no, like.
Oh.
If I just do a straight line over the 2 and then straight line going up. So
It's negative. It's a -1 slope, then a -0.5, and then a 0. It's got to take on all those values in between instead of just stay. If it were an absolute value, then you would be going like, it would have a slope like this.
just straight across.
Yeah, your slope would be just a single value. So no, the slope is changing, so it's got to be roundy. And it's got to go from coming down to going up at 2. And then it stops when we get to 3, or yeah, we get to 3 right there. So you shouldn't go beyond what they represent here. Crazy, huh? Indeed, yes. I will tell you this. You will have some sort of a parabolic shape and some sort of a line someplace in it. So that'll help you a little bit. So you could design derivative graphs for yourself all day. Just give you a point that goes to the point that it has to go through. Maybe put the parabola over here, make it go upward. Make this, put it over here, make it go down. Put your line over here going this way, or your line going this way. There's all sorts of things that you can do that you can give yourself to practice this. But this is all you're getting for the review. If you want me to help you come up with those, we can do that. But maybe what you should do is, when you get a chance to study together, is draw ones you feel like will challenge your buddy and see if they can do it. But before you draw yours, you better have an idea what the answer is so you can check it. But I would practice this more. I mean, watching me do it and working through this together, nothing like it is on the test. You don't get me to help to discuss things with you, and you don't get your friends to discuss it with you. You better be able to draw one of these and draw the correct value for it all by your own, as my Alex says. All by my loan. All by your loan. Get it? Okay, so that's what you're up against for number 2. You'll get a point that it has to go through, and a picture of a derivative graph. Make sure that you remember the derivative graph is a picture of slope values. Gotta make that apparent in your drawing. Okay. Others? Yeah.
Number 4, it's using the ender to graph derivative of a function.
Uh-huh.
What will the answer box look like on that? Will we have to graph the derivative?
Looks like this. No, there's no graph.
Okay.
It's just answers. A says, what does your calculator tell you the derivative is?
Okay.
And you have to decide if the calculator is correct and if not, why.
Well,
So what it says is, this is how it's phrased. I'm not gonna actually give you the function, I'm not gonna tell you what it is, but it will give you a function and it will say, well, I'll give you a sample function. It's not this function, but I'll give you a sample. F of x equals the absolute value of x minus 3. Find, this is how it's written, just so you understand the notation. He writes Ender, the author of the test, the author of the book who wrote the test, of f of x, comma, 3. And what he means is, find the derivative, use your calculator to find the derivative of this function at 3. And write the answer. What will it tell you it is, or what have you discovered it is? 0?
It says
It says it's 0. So for the answer, in the answer column for A, you will write 0. B part says, on the test, it says, and I'm not going to write it all out. It says, is your answer to part A a meaningful estimate of the derivative of f of x? You got to answer yes or no, and the answer is, in this case, no. What's your explanation?
because it's not, the slope is different from every other point except that one.
Okay, it's easier than that.
Okay.
You've decided the answer to the question, which was, is this a meaningful answer for the derivative at 0? I mean, at 3. And your answer, you've all decided the answer is no for this case, right?
Yeah.
Why? Because there's a corner. That's what you're right. Because there's a corner there. Quarter. That's all you got to write. Corners don't have derivatives. Yes.
So like if it were to be like a tangent thing and it said find it at like pi halves, then would the calculator give you like 10,000 or something like really big?
Yep.
And you would say no because it's.
Because there's an asymptote there. Or because the function is not defined there. Or there is no derivative there because there's an asymptote instead. Something like that.
Okay.
Okay. What will happen on the tangent curve that you were just talking about is at pi halves, it goes up like this, and then over here it kind of starts coming out like this again. And it will make an attempt to find the slope between these 2 points crossing that, and it will be a very, very high negative number. And you would write that really high negative number for A. And then down here you would say no, because at pi halves there's a vertical asymptote which cannot be crossed, or there's no tangent there, something.
It's gonna sound stupid, but how do you find the derivative in your calculator again? You go n deriv, and then.
Then you type in the function.
The function with respect to x, you have to write x.
Function comma x. That's the respect to x.
Oh.
Are you using pretty print or
No, I like the.
the classic?
Yeah.
Then you need those 3 things. You have to write the function, comma, with respect to x, comma, at this point. Yeah, you all remember how to punch it in with whatever version, classic or the new version, pretty print version?
If B is yes, you have to yes and leave it. Don't say no.
If it's yes. It just says, is your answer to part A meaningful estimate of the derivative of f? And if you wrote yes, then it does say explain. You'll have to give an explanation. Say,
Yes.
But probably
because at this point on the curve, there's a derivative. The derivative exists or something. And is this value?
This is what, just
it's not differentiable. It has a corner because
We probably write the derivative as defined here. Other questions or more discussion on this if you like? Everybody got their calculators handled? You're good?
Yeah.
Okay. You have to write with respect to x. That's the part that people forget. Other questions?
Page 153, number 23.
And this references which one?
Number 9.
Number 9? Okay, give me the page reference again.
153, number 23.
Number 153, number 23. And this is for number 9 on the test?
Yeah.
Okay. Y equals 1 plus the cosine squared of 7x cubed. Whew.
What's going on there? Probably start with the chain rule there.
That's a good idea.
That's what I would do as well as also.
Okay, read me the function again.
1 plus cosine squared 7x.
Cosine squared of 7x.
Yeah, all of that cubed.
Okay, so find the derivative of this, and by the way, on the test, that's all it says for number 9. It says, this is what it says. Find dy dx, just so you understand it, this is how it's worded. Find dy dx if y equals this. That's what it's saying. So find the derivative. What's the first step? Now, what do we deal with first?
Exponent. Parentheses.
Yeah.
It's gonna be 3 times.
We're gonna deal with the cube first, aren't we?
Yeah.
Okay, 3 times
1
1
cosine squared 7x squared.
Good.
Yeah.
And then you're gonna do it inside.
Times negative sine squared 7x. Wait, no.
Yes.
No,
Because
we
wouldn't it be
need
like
Negative
0 minus
two.
sign?
Negative 2 sine squared.
Wait, no.
Wait a second.
Two.
Let's just do the 2 sine squared.
Okay, yeah, that's
No, not the 2 sine squared. 2
Cosine.
sine 7x, right?
Isn't it negative?
Wait a minute. No, that's wrong.
Nope.
2 cosine 7x
Okay.
times
Where does the 1 go?
All the ones that come.
Negative.
negative
Sine.
sine
7x
7x
times 7.
times 7.
Wait a minute. Okay.
It'll make more sense to you, and it'll be happy for you people if you do this, if you remember to do this, to write this like this. It'll be easier for you to tell what's going on.
Why is it 4 on the front of the cosine?
It isn't, it's 14.
So you get the 2 from the square,
Right?
and then you keep going.
You have to multiply by 7x, or by the derivative of 7x eventually.
And 2 times.
Oh.
That's-
So really, folks, it ought to be this. It ought to be negative 42 times 1 plus the cosine squared, 7x, times cosine,
Isn't that whole thing squared?
yep, times the cosine of 7x sine 7x. If you got really crazy with identities, I suppose you could rename this as something, but I won't require that. Okay? I will tell you this, the one you have to do on the test has not got that many pieces of chain link,
That's good.
but it does have one of the rules, either product or quotient, so be aware of those. Okay, so that was a reference to number 9. This right here was. I'm gonna get rid of it all again so I can start from scratch for this video. Okay, what else would you like to discuss?
Question.
Yeah.
Number 11 on their view says it's exactly like number 9. Is the question in your English system?
Yeah, just let's leave that.
They ask exactly the same question. The functions that you have to find the derivative of are quite a bit different from one another. However, both of them involve trig functions. But we just did number 9. I want to warn you about something on number 11. Here comes the warning. They'll ask you to find something, and it looks deceptively simple at first, at the outset, but then people forget how to handle a certain thing. I'm going to show you, okay? So on number 11, it says find dy dx again, and y is something like this. Tangent of 3 over x squared. So what's dy dx on this?
Well, first it's gonna be sine
Squared.
Secant squared of 3 over x squared, right?
Yeah. You're gonna have to times that.
Yeah, it'll be times by. You could quotient rule it if you want.
There was a trick to it. You thought it-
Bring the negative to us.
Yeah. A little piece of scratch paper over here, which we'll deal with. This is scratch paper. I want to derive this 3 over x squared, and I'm going to name it 3x to the negative 2 to do it. That's what I'm going to do. Which would be
Negative 6x.
negative 6x to the negative 3, which is
Negative 6 over x cubed.
right. Negative 6 over x cubed. And if you wrote it like that, I'd give you full credit. You don't have to simplify that if you don't want. What happens to people is they see these two right next to each other and they start multiplying them. That's dumb. Don't do that. That's dumb. This belongs to that secant. You can't multiply this times that little piece of it.
So if you did try and simplify it further, it'd just be negative 6 secant squared of 3 x squared over x squared.
Yes. That would be okay. But don't multiply this piece of that secant times this and think that's the secant of all of it. It's not. That would not be good. That's happened before. I look at it and go, okay, be careful with that, okay? So that's just a little warning about number 11, that you will have to deal with the thing that you're tangenting or trigging. Whatever you're trigging there has got that funny little quirk to it. Other questions?
Not so really dumb, but can we just do number 1? We just,
That's a good idea. Let's do it.
Have you got a sample for me?
it's, yeah, it's like number 2, it's.
It's okay to ask about number 1. We haven't seen it in a long time.
Yeah, it's x squared plus 4 equals 1.
That I gave you,
Yeah.
that's on the,
Well, it says like number 2, page 105.
number 2, page 105. That's where we're going for those of you who are watching.
Oh, I forgot. We did it.
You were listening.
That's probably for Jefferson.
Good grief, this chapter's long.
Jefferson.
102,
It's just like 80 pages.
not 102.
105.
105, sorry, 105, number what?
2.
2, okay. Once again, was up most of the night with the baby. I am not. I guess I'm not. He's fun to be with, but he can't function the next day. All right, number 5. 1 over x at a equals 2.
Number 2.
Wait, number 2.
Oh.
So it's x squared plus 4.
X squared plus 4 at a equals 1. Whew. Okay, I personally, and I've taught you to do it this way, so I'm hoping that you do it this way as well. I am not going to use that a equals 1 in the development of this. I'm going to find it, and I'm going to find myself a slope generator in terms of x using the definition. And then I'm going to plug a in. Is that okay?
Yeah.
All right, so I'm ignoring that for the moment. And I'm going to find the derivative using the definition. F prime of x is equal to the limit as h goes to 0 of f of x plus h, x plus h squared plus 4 minus all of x squared plus 4. This is f of x plus h minus f of x. Now, if you want, you can write out the actual generic definition and then plug these in, or you can just dig in which is what I'm doing. Either way is fine, as long as I can see you using f of x plus h minus f of x all over h. Somewhere now you got to show me you're doing that. Then we do the algebra on this. You can leave the limit out as you're doing this, but make sure you bring it back. It's going to be x squared plus 2xh plus h squared plus 4 minus x squared minus 4 all over h. You can expect these to add out. And then what remains has h's in it. Show me what happens when you divide it out. You get 2x plus h. Then bring the limit back. And that's going to be 2x at x equals 1 is 2.
Hey, on the test, will it have one of those things where it's like h over h is 1?
Possibly.
So when would that happen again? Like, if the h squared on the top was just h, that would be.
That would be if you're trying to find the derivative using the definition of something like x squared plus x plus 4, because the derivative, as we know from doing the tricks, is 2x plus 1, and that's where that 1 will come from, is an h over an h.
Okay.
If your linear term has just a coefficient of 1 on it, that's how you're going to get that 1. Is you're going to have an h over h term, which is 1. Okay?
If it's a negative h over h, then it's not as well.
You serious?
So, is that satisfactory?
Yeah. that should be
Kyle?
good. That should be good.
Okay, you need to show all of that somewhere or another.
Okay.
Well, not that junk over there that I had a discussion with Landon on.
That's not bad.
That's all right, I'll just get rid of it. This is what I expect to see. And it would be kind of nice so that I know that you did it right. Well, at least you know how to take a derivative. Put the 2 in the blank and then say, see back a page or something. Show me where I'm looking for the process. Just direct me to a place to go. Anything else?
Number 5 was kind of tricky.
Yes.
Number 5 is not tricky. What is it referencing? I'll tell you why you think that.
Number 1 through 6, page 124.
124, 1 through 6. Is that what you said?
Yeah.
Oh, right, is this just the second root?
Yeah.
Yes.
1 through 6, page 124, and it says, find dy dx.
But then this
But
one says
Yeah, the
dy.
instructions say find the second one.
Yeah.
Okay, the instructions on your test for number 5 says find A, dy dx, and B, d squared y over dx squared. And what you have to find the first and second derivative of is a polynomial.
That's good.
Nobody misses it. Okay?
Okay.
They just want to see if you understand the notation, find dy dx and find d squared y over dx squared.
Can we do number 8?
Just real quick, before we go there, can we do like number 5 just with the x cubed in the directions?
You want to do it over like
Number
number
2.
Number 5.
Number
number 2?
Number 2 on 124.
Okay.
Number 5.
Number 5.
Y equals x cubed over 3 minus x?
Yep.
That's really just 1/3 x cubed minus x.
Oh, just kidding. Yeah, we're good.
That's okay, people forget that. But yeah, that's just 1/3 x cubed on the front.
Which would be 3/3 x squared. Which would be x squared.
Thanks, Kyle.
Yep.
Hope you heard that on the thing, see, he's taking care of that. Landon, for all of you, just to set your mind at ease for number 5, it's a polynomial and all the coefficients are whole. Nobody misses this. Okay, what else?
Number 8,
I'm sorry, number 8 on
or 5 and 6 on page 135.
135.
135.
135. Okay, we're going to page 135, numbers 5 and 6, and it references number 8. On the test.
Yeah, when your way would have been nice.
Okay.
I agree.
All right, here we go. Number 8 on the test is just like 5 and 6 on page 135, and you will be given a horizontal table just like these. And the one on the test is time in seconds, just like these. And this is what you're supposed to do. You are supposed to plot S versus T and sketch a smooth curve through the given points. This would be a task I might give you if you were in pre-algebra. Just plot points in connection. That's the A part. There's nothing you have to do. You have to derive it. You don't have to nothing. It says plot S versus T. That's like Y versus X. And sketch a smooth curve through the given points.
So you just grab the points, select a 0, you do the associated.
Yes. You would plot the point 0, 1.5.
Is it really that easy?
It is. And so, yeah, don't talk yourself into something tougher. Not the A part. Not on the A part. Okay? So,
Not yet.
for A, it says plot S versus T and sketch a smooth curve through the given points. That's all you gotta do. Then, B part is where the calculus comes in. And it says, assuming this smooth curve represents the motion of the body, whatever it is that's moving, estimate the velocity at. Now, do you think you're gonna do that with the graph that you drew? No, you're not. That's not the best way to estimate by just looking at the graph and saying, that feels about, yeah, no. That's what it seems like the author wants you to do. Well, the reason he has you draw the graph with the smooth curve through it is so that when you do figure, and you do have to figure your estimate at 3 points, you can look at your graph and say, yep, I think I'm right. You understand?
So,
But you're not to use the graph to make the estimates. That'll lead you down bad. Because your estimates can never be as good as what you can figure. So, let's say, on number 5, will you look at number 5 with me?
Yeah.
Let's say that I wanted you to estimate the velocity of the body, whatever's moving, at 1 second.
That would be 36.5. Oh, just kidding, that wouldn't be there.
That's the position. How would you figure out or do a good estimate, try to find an estimate of the slope? That's what you're doing. Find an estimate of the slope of the curve or the speed, which is velocity, at 1 second. Now look closely at the numbers and I'll tell you. You gotta have your eyeballs on on number 5, looking at 1 second of time. You would figure that by taking 44 minus 26 over 1.5 minus 0.5.
wait a minute, say that again. So you do 44
Minus 26 over 1.5 minus 0.5.
Is this multiple choice? Or
No, and then what kind of strange thought is that?
The reason why that works, folks, and I don't know if you're familiar with it. I think I did draw this at one point, but I didn't spend a huge amount of time on it. That's my fault. We'll spend lots of time on this later, but for right now, you're being tested on it. The reason why doing what I just told you to do works is because if you've got a piece of curve, I'm this on purpose. If you got a piece of curve that comes out like this, and this right here is 0.5 seconds out down here on the x-axis, and this right over here is 1.5 seconds. And this right here is 1 second right here, and this is a position curve, then this slope is pretty darn close to that slope because if you're not very far away from this, I had to make it dramatic for you, but if you're not very far away, you use points that are as close as you got data for from this point on either side, the secant line between these two is going to be pretty close to the tangent line there. Look, they're parallel almost. And that's the best you can do to estimate if you've only got a certain number of points. So do you understand what I said? You take the 2 points around the one you're trying to, the x value you're trying to do, and you find the slope, because that would be the slope between this one and this one. Be about the same as the slope as that one. You see what's happening?
Yeah.
You'll have to do that 3 times. So you look at the table, and when it says find an estimate for the velocity at 2.5, what are you gonna do? 48.5 minus 48.5, right there. All the good estimate is 0 for that one, right? Okay. So you have 3 points where you're gonna have to do that, and you would use the table to make your estimates, not the graph itself, but you can look at the graph that you drew in A just to verify that you got it probably correct. Anything else, anyone? Let's see, we covered 1, 2, didn't talk about 3, talked about 4, 5, haven't talked about 6, we did 7, so we haven't talked about 3 or 6. We talked about 9.
We haven't done 12 through 16, 17.
We haven't went to the
Is
second half
16 and
of this yet.
17 the same thing?
Yeah, let's do 3 and 6. Good idea.
No, 16 and 17 are not the same thing, but they both deal with exponents and logarithms. What do you want to talk about? 3 and 6?
Page 114. Don't fall asleep, Kyle.
Number 3, what page am I on?
114.
114. Just a minute. Let me get there, just a minute. There's only one thing.
Oh, yeah.
Even though I am a woman, I'm tired. 114, number.
11 through 15.
Okay. 11 through 15 says the function fails to be differentiable at a certain point. Tell whether the problem is a corner, a cusp, vertical tangent, or discontinuity. On number 3 on the test, it is multiple choice.
Ooh. Hey, did you hear that?
Your choices are, listen, shh. Your choices are A, differentiable, B, corner, C, cusp. If it turns out to be a corner or a cusp, if that's what it is, I will give you credit for either B or C. I don't care which one you call it. D, vertical tangent, E, discontinuity. So it's possible that it's differentiable. And if it is, you would choose A.
Yep.
If it's not differentiable, then its problem will be either a corner, cusp, vertical tangent, or discontinuity. The best way to tell, in my opinion, is to graph it. Get your cursor using your trace key. Get your cursor on the X point of interest and zoom in and zoom in and zoom in. And if it becomes linear, then it's differentiable. If it looks like it has a corner at first, continues to have a corner at that point, then choose that. You could also find the derivative, and it'll tell you whether it's differentiable or not, but it won't tell you what the problem is until you graph it. You know what I mean? Okay? It's not worth very much because it's multiple choice, and I think it's not glaring, but I think it's pretty easy with a little manipulation of your calculator to tell what's going on. Okay, number 6. 6 is that one that is really easy arithmetically, but not unless you know what you're doing. It's a test to see if you remember the details of your product rule and or quotient rule. Could be both. Oh, it is both. It is both. Okay. So give me a reference on this one so I don't have to make this up myself.
144.
6, okay. 124, number 24. Page number and problem we're going to. Have you guys looked at this and you're not too concerned about it? You're not too concerned? If you know what to do, it's not very hard. Okay, let's look at 24. It says, suppose u and v are functions of x that are differentiable at x equals 2, and that, somebody read me those. U of 2 is 3.
U of 2 is -4.
V of 2 is.
V of 2?
Yeah, is 1.
V prime of 2 is
Okay? This is the kind of information they'll give you on the test. And what they would like you to find with this information is, well, any of those things would be acceptable. I will give you a little bit of variation like is on the test. In 24A, it says find ddx of u times v. On the test, when they ask you to do something like that, it's going to be find ddx of 5u times v. Now, you should understand that that's the same thing as finding this. It's also the same as this. You can even put the 5 at the v if you want. It'll all come out in the wash if you do it right. I prefer this myself. It's just me. It's just a personal choice. But this is what they want you to find. So you have to remember the product rule. What this would be if you did it my way, like that, would be the first times the derivative of the second plus the second times the derivative of the first. Yep. Okay, so what is u at 2? Oh, by the way, this will be at 2.
Where'd the 5 come from?
I made it up because it's like that on the test.
Yeah.
So this would be 3 times 2 plus 1 times that's what I think.
I think that as well.
Okay, this will be 30 minus 20. That's what you put in the blank. Okay? Now, the B part might ask you to do something like this. Find the derivative with respect to x of 2u over v. Okay, and that would be bottom times the derivative of the top minus
all over.
okay, and when we plug that in, that would be what? What's v? What's u prime? Would be -8 when we plug it in, okay?
Yep.
Minus 2 times,
3 times 2, which is 6.
But
sorry,
3 times 2.
2 times 3.
what's u?
It's
3.
uv or v prime?
2.
Bottom squared?
1.
Oh, that's nice.
Yep.
-8 minus 12?
Yep.
Okay,
Bing, boom.
okay, so that's all it is, but you gotta know what you're doing. Gotta remember your rules. It's a good way to test your knowledge of both rules, it's not hard. Okay,
Yeah, maybe I was right or
Maybe we
something.
should
think
take
you
the
were
first
right.
half tomorrow.
what was right?
I said
I
maybe
was
we
right.
should take the first half tomorrow.
Can we switch?
It's
I would like
Yes,
to
if
take
you
it.
want.
Yeah, I want to do it tomorrow. Let's take one.
Because haven't we done one through?
Okay, vote again. How many of you would rather take the first half tomorrow?
No, good, come on. Come on, guys.
Come on.
Guys, Brent's
So then
voting for-
Wednesday, we'll finish doing the rest of the test, for the rest of the review, and you can study and ask any questions you want, and then take the rest of it
Thursday?
Thursday.
Yeah.
Yeah, that's
Good
not
plan.
nice.
So how many questions are gonna be on the one tomorrow? Like,
Numbers
which one?
Numbers 1 through 8. Just so you know, numbers 1 through 8 are on the test tomorrow. 1 through 8 on the test tomorrow, okay? So I guess we're done because we're out of time. There will be another recording of Review B later. See ya.